In this video, we're going to talk about end behavior of a function and horizontal asymptotes. When we refer to end behavior of a function, what we're talking about is what happens to the graph as you go out to the left or to the right of the graph. In terms of limits, what we're talking about is the limit as x approaches infinity or x approaches negative infinity. And then we're going to classify those end behaviors as bounded or unbounded. Going to be bounded if it's approaching a particular value and has a horizontal asymptote, unbounded if it approaches positive or negative infinity, or in other words, if it's just going up or down forever. Taking a look at the four graphs here, we can see on this first graph, my limit as x approaches negative infinity, so that to the left we're going up, so this is going to be positive infinity, and as x approaches positive infinity on the right side, we're also going up, so positive infinity. In this case, then, we would refer to the end behavior as unbounded, since both of those limits are approaching either positive or negative infinity. On the second graph here, the limit as x approaches negative infinity, so as we're going to the left forever, we're going down forever, so we're approaching negative infinity. The limit as x approaches positive infinity is going up forever, so the answer is going to be positive infinity there. Again, in this case, because both of our end behavior limits are positive or negative infinity, we're going to call that end behavior unbounded. On the next graph, as x approaches negative infinity, so I'm going out this way, we seem to be becoming horizontal here and leveling off, so we're approaching a particular value. That value is where this asymptote is here, which looks like it's at 3. As we go to the other side and we go to the right, as x approaches positive infinity, we're hitting that same asymptote, so 3 again. These values are not involving infinity. Here we're going to say that our end behavior is bounded. And then looking at this final graph, as x approaches negative infinity, so as we're going out to the left here, we seem to be approaching the axis, so it looks like the asymptote's on the axis here. So we would say the limit is 0. Same thing on the right-hand side, we're approaching that axis, which is 0. So again, since my limits do not involve infinity, then we're going to say that the end behavior is bounded. So notice on the two examples where the end behavior was bounded, we had a horizontal asymptote on that graph. So if we talk about the horizontal asymptotes, the horizontal asymptote comes from those limits as x approaches positive infinity or x approaching negative infinity. So looking at this first graph here, we can see that we would have a horizontal asymptote here, y equal -2. And that's because the limit as x approaches positive infinity and the limit as x approaches negative infinity is -2. On the second graph here, we're going to have a horizontal asymptote on the axis. So here my asymptote is going to be at y equals 0. So again, my limit as x approaches positive infinity is approaching the axis, and my limit as x approaches negative infinity is approaching the axis. So my horizontal asymptote is at y equals 0. In order to find horizontal asymptotes from rational functions, which is where most of our horizontal asymptotes will come from at this point, we can use some rules about the degree of the numerator and the denominator. So the first thing we would do is find the degree of that numerator and denominator from the rational function, and then we have to know these 3 rules. So if the degree of my numerator is less than the degree of the denominator, then my end behavior is bounded and my horizontal asymptote is y equals 0. If the degree of my numerator is greater than the degree of my denominator, then the end behavior is unbounded and we would have no horizontal asymptote. And then finally, if the degree of the numerator is equal to the degree of the denominator, then my end behavior is bounded again, and my horizontal asymptote is y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. So if we take a look at a couple of examples from here. Here's a rational function 3x over x squared plus 1. So we can take a look at the graph of that on the calculator, which we will get this picture over here. The degree of my numerator is going to be 1. The degree of my denominator is going to be the 2 here. So the degree of my numerator is less than the degree of my denominator. And then according to my rules, that tells me that my end behavior is bounded and my horizontal asymptote is going to be y equals 0. We can see on the graph then that my horizontal asymptote would be along the axis here. So looking at a second example, my degree of my numerator is going to be the 2. The degree of the denominator here is also going to be 2. So the degree of my numerator equals the degree of my denominator. The leading coefficient in my numerator is the 3. The leading coefficient in my denominator is the 1. Since we don't see anything there, we know that it's the 1. So this is going to tell me that my end behavior is bounded and my horizontal asymptote is y equals 3. And then one more example here of the degree of the numerator here is 3. The degree of my denominator here is 2. So the degree of my numerator is greater than the degree of my denominator. And then again, from my rules, that tells me that the end behavior is unbounded and there's no horizontal asymptote.